So we're looking at ways of testing association, correlation, between two variables for the purpose of using it as evidence of causation. We've looked at two common cases. One is where you have two quantitative variables. We've been using job performance and job satisfaction as our two variables. With two quantitative variables, we will use linear regression or Pearson's correlation coefficient, the most common ways we do it. Then secondly, we looked at a situation where both variables are binary categorical variables. So high or low job satisfaction, high or low job performance. We produce a 2x2 contingency table, and then we can do an analysis with the phi coefficient of correlation and a confidence interval for the odds ratio. That enables us to draw a conclusion about population from a sample. The final case I want to look at is one that should be fairly familiar, which is where one of the variables is a binary categorical variable. In this case, high satisfaction, job satisfaction, or low job satisfaction, and the other variable is quantitative, in this case job performance. Now, we've looked at a number of ways of testing for statistically significant differences, comparing box plots in various ways and so on. I think one of the best ways, so long as you remember how to actually produce them, is to use the notched box plot method. It has the advantage of it, it combines a visualization with an actual test for a statistically significant difference. And you should be pretty familiar with these now and how to create them. In this case, so what you're looking for when you do this is you want the box plots to be reasonably typical box plots. So if you have a box plot which is a single vertical line and a dot, that's going to be a very unusual set of data, and that's going to create problems for any test of significant difference. But if they're reasonably normal looking box plots and you can put in the notches and the notches don't overlap, then you can make a claim about a significant, being 95% confident of a significant difference. So that one is pretty straightforward. We haven't looked at some other possibilities. So the ones I've introduced in this course, those three sets of methods there, they're probably the most common ones. They're really useful in many situations. The next sort of steps that you get to are where one or other of the variables is perhaps categorical but has more than two levels, or where you have ordered categorical variables and so on. There's a number of other possibilities that come into play in the real world. But even with these three methods that we've covered in this course, there's really quite a lot that you can do, particularly if you want in a position to conduct field experiments in an organization. So I'll finish this video here. We're going to move on next to what is really the biggest and most complex set of issues around evidence of causation, and that is dealing with the problem of alternative explanations, or what are sometimes called confounding variables.